senior officers and brother officers, ladies and gentlemen. Today we are going to present our engineering students and our team effort how we develop smart GSM phone jammer. So in this project work, this is our crew or our team, and how we are going to conduct this presentation as appeared on the screen. Today we had a plan to demonstrate the system we developed, but due to the lack of availability, and so we like to show it as a video clip. So in cell phone jammers are the devices that create temporary dead zone to all cell phone traffic in their immediate proximity. You know, today everybody using mobile phones. Sometimes one person has more than one or two mobile phones. So the mobile phone usage has become uncontrollable. Since the increased number of the mobile phone users, the need to disable mobile phone in specific places where the ringing of cell phone would be disruptive has been increased. Therefore, the necessity of phone jam has been improved at special places and special occasions. Mobile phone, cell phone jam, prior to the cell phone jammers, actually these jammers invented in the military sector especially, because the jammers we developed in the communication jammers need to deny the effective use of enemies friendly use of communication. Actually, to prevent that purpose, develop the communication jammers. When it comes to the mobile phone jammers, they develop because of these various requirements. The requirements are because, like a conference like this, some people forget to switch off their mobile phone. So we want to make a system to, without knowing to him, to switch off his mobile phone for a while. So in our endeavor, the smartness, because the mobile phone jammers are available in everywhere in the world now. Not everywhere, the few are available. The smartness of this project can detect a mobile phone. If you come here with the switch on the mobile phone, our system can detect it. It detects the mobile phone when he is going to receive a call or he is attempting to take a call. After detecting, there is a small time gap to have a handshaking period to start the ringing. During that particular period, we initiate the jamming signal. We emit the jamming signal. So, due to some constraints, we develop here as a prototype. In this prototype, we go up to the VCU, not the power amplifier level. So, with that, I would like to show the aim of our presentation. This has appeared on the screen, and I like to show a block diagram of our system that we develop actually. In our system, what we thought to have is distributed detectors, because the detecting of a mobile phone, availability of a mobile phone with the resources we had, so far it is about limited range, somewhere around 2 to 3 radius of the range. So we had a plan to keep the detector in a distributed locations. So we get it to the microcontroller, and from the microcontroller it's switch on a jammer. When the jammer is switched on, the radiates coming from our jammer can affect to our detector itself. So prevent that, at the same time the microcontroller switch off our detector circuits, and it kept extra time amount, delta t time amount, to switch on again the detector after switch off the jammer. This is the concept, and this is the method technique we adopted in our system. I would like to invite Cadet Senarath to continue with our presentation.
Thank you, sir. Mainly, there are available 5 types of mobile signal jamming techniques, which you can see on the screen. Let's understand how cell phone jammer works. A jamming device transmits same radio frequency of greater power than the cell phone. It disrupts the communication between the phone and cell phone base station. This is called a denial of service attack. This causes interference with the communication of cell phones and tower to render the phones unusable. On most phones, the network would be out of range. So jammers work by either disrupting, uplink or downlink. Our design parameters were frequency band, distance to be jammed, jam into signal ratio, free path loss and power calculation. Frequency band. The frequency of the transmitted signal of the jammer must cover the GSM frequency range. As the power received from the base station is usually low, it is easier to jam the downlink than uplink. Hence the jammer output frequency should cover the downlink frequency. Jam into signal ratio. For GSM, the specified system minimum signal noise ratio is 9 dB, which will be used as the worst case scenario for the jammer. The maximum power at the mobile device is minus 15 dB. Free space loss. The free space loss is given by this equation. The maximum free space loss happens when the maximum frequency is used in the above equation. So in Sri Lanka, 1880 MHz. Using 1880 MHz, that equation gives 58 dB. Power calculation. Here, we need to find the power that is needed to be transmitted to jam any cell phone within a distance of around 10 meters. From the above consideration, we can find the required output power from the device. As you can see, using signal noise ratio 9 dB and the maximum power signal for mobile receiver minus 15 dB, it gives minus 24 dB. But our goal is to find the output power from the device. So when we added the free space losses to the amount of the power at the mobile receiver, we get our output power 34 decibels. We did the hardware design under following 5 stages: circuit analysis, power supply, the IF section, RF section and antenna. The implementation of type A jam is fairly simple. The block diagram for this type is shown in the figure. It shows the main parts, which are RF section, IF section and the power supply. Power supply is used to supply the other section with the needed voltage. Transformer is used to transform the 220 volt AC to the levels of voltages. Rectification part is convert the AC voltage to a DC. We have two methods for rectification: half wave rectification and full wave rectification. A rectified output voltage occurs during the both positive and negative cycles of the input signal. The filter is used to eliminate the fluctuation in the output of the full wave rectifier, so that a constant DC voltage is produced. This filter is just a large capacitor used to minimize the ripple in the output. Regulator is used to provide the desired DC voltage. Here we use a PC power supply unit as shown in the screen for both jammer and the detector. IF section. The function of IF section of the mobile jammer is to generate the tuning signal for the VCO in the RF section, which will sweep the VCO to the desired range of frequency. Mainly IF section consists of 3 parts: triangle wave generator, noise generator and the mixer. Main use of triangle wave is to sweep the VCO to the desired range of frequency. We use 555 IC operating in a stable mode to generate the sweeping signal. The output frequency depends on the charging and the discharging of the capacitor, resistor values and the power supply for the IC. In this design, we used a noise generator to achieve a jamming noise signal is mixed with the triangle wave signal to produce the tuning voltage for the VCO. Without noise generator, the jamming signal is just a sweeping demodulated continuous wave RF carrier. The noise generator used in this design is based on avalanche noise generated by the Zener breakdown phenomenon. The triangle wave and noise signal are mixed using op-amp configured as summer. It shows on the screen. The RF section is the most important part of the mobile jammer. It consists voltage control oscillator, RF power amplifier antenna. The voltage control oscillator is responsible for generating the RF signal which will overpower the mobile downlink signal. Since 7 decibel output power from the VCO does not achieve the desired output power of the GSM jammer, so we had to add the power amplifier with a suitable gain to increase the VCO output to 34 decibel. A proper antenna necessary to transmit the jamming signal. In order to have optimal power transfer, the antenna system must be matched to the transmission system. In this project, we use quarter wave length monopole antennas with 50 ohm input impedance so that the antenna are matched to the system. This is the circuit diagram of detector which has been used for this design. These are the main component of circuit: capacitor C3, CA3130 IC1, NE555 timer IC2, transistor, and light emitting diode. Let's clarify the basic operation of the detector. In our circuit, capacitor C3 intercepts the signal from the mobile phone. This capacitor creates a field, stores energy, and transfers the stored energy in form of minute current to input of IC1. This will interrupt the balance of IC1 and convert the current into a corresponding output voltage. The output CMOS transistor is capable of swinging the output voltage to within 10 mV of either supply voltage terminals. This triggers the monostable timer IC2 through capacitor C7. Capacitor C6 maintains the base bias of transistor T1 for fast switching action. The low value timing component R6 and C9 produce very short time delay to avoid audio nuisance. This is our result. We get those graphs by a spectrum analyzer. As you can see in the figure 1, there is no mobile phone in the active. In the figure 2, you can see there is a mobile phone is activated. In the figure 3, as you can see, it is we get after our jammer jam the whole GSM 2 ranges. Application of jammers. To maintain the complete silence in library and lecture halls, to avoid fraud in examination hall, to avoid disturbance in classrooms, for providing security in conferences, board of direction rooms, seminars, etc. For providing calm and peaceful atmosphere in hospitals, church, temple, religious establishment, and military establishment. You can see initially all the cell phones in full range. Here you can see our jammer and the detector and the microcontroller. Here we are try to get a call. Now you can see that detector detects the call, and we can see it by blinking the LED. Now you can see that phone is ringing.